Hello students, you are up to Dr. Ogunshola's class. In this video, we shall be talking about Napier's rule. Napier's rule. Please don't forget to click the notification button so that each time I produce new video, you'll be duly notified. So let's look at what meant by Napier's rule in mathematics. These Napier's rules are very useful for solving right-angled spherical triangles in spherical trigonometry, particularly in navigation, geodesy, and astronomy. For a right-angled spherical triangle where C is equal to 90 degrees, the sides and angles satisfy Napier's rules of circular path. Now, what are the rules of Napier? Let's look at the rules of Napier 1. The Napier's rules are rule 1. The two right angles, the two non-right angles, let's say A, B, we have the two right angles, that's one, there will be A, B, when you're talking about triangle ABC. It also have the two complementary sides. It has the two complementary sides opposite to these angles. So what do I mean by this? Before I go further, let me draw. Let's say this is a right angle spherical triangle. Okay, this is C, this is A and B. So, you know, the angle A is facing this side, so we call this one letter A, that's a slip of tongue. And the angle C here is facing this side, we call this letter C, small letter C. While the angle B here is facing this side, we call this one small letter B. So, this angle could be called 90 degree minus A. This will be called 90 degree minus B. Okay, so in a spherical right angle triangle or right angle spherical triangle, we have the constant angle here is C. That's why we call it right angle. But the sphericity of the triangle comes into play when you consider the sides, the complementary sides. Now, there are two complementary sides here. This is a complementary side. This is another complementary side. Okay? Now, these are the sides that faces the included angle. So, these angles now are, we have the two complementary sides opposite to these angles. They are 90 degree minus A and 90 degree minus B. Okay? Those are the complementary angles we have there. Now the third one here, the third one is the hypotenuse. The third is the hypotenuse. The third is the hypotenuse. The hypotenuse C. The hypotenuse C. That is the third. Okay? Now, what does the rule state, or what does the rule say? Without wasting our time, the rule states that each part has two adjacent parts and two opposite parts. Each part of the triangle has two adjacent. So if I take this part now, say for example I take this part, this side, it doesn't have this side and this side. If I take this, it has this side and this side as the adjacent parts and the two opposite parts as well. So picking any of the sides, this side, you can see this particular side is facing this angle. This particular side is facing this angle. And just to mention a few. Now the sine of any part equals to the product of tangents of its two adjacent parts. While the cosine of any parts equals to the product of cosines of its two opposite parts. Now we shall explain this mathematically later. We shall explain this. Let's write out the major important formula that we need to consider. Now we have, these are, we can have tan b minus c all over 2 is equal to b minus c all over b plus c, cot a all over 2, cot a all over 2. The technique is this. If, like I said, suppose this is the right angle spherical triangle, and this is point C, and this is A, this is B. So we had A plus B plus C is automatically going to be what? 180 degrees, because in any triangle, the sum of angles is equal to 180. So now, if you have taken B and C, it means you'll be having only A left. Okay? Now, if I divide through by 2, I will have everything here over 2. That will be 90. Because so A plus B plus C all over 2 will be equal to, this is what I'm saying. A plus B plus C all over 2 will be equal to 90 degrees. So I can have this as, I will show you this in the examples I'm going to solve here. Let's continue with the formula. I will show it, don't worry. 2, we have tan C minus A all over 2 will be what? C minus A, which is the adjacent sides facing the angle C and A, all over C plus A, and the inverse of tan will be what? Cot, what do you have left now? We have taken C and A. This one what? B all over 2, the cot of angle B all over 2. That is that. Now the third one, tan A minus B all over 2. That will be what? Small side A and B, the difference between them, all over A plus B. Now what do you have left now? We have taken A and B. It remains C. So that will be the inverse of, that is cot C all over 2. Take note, this C is capital C. It's talking about the angle. So these are important formula we need to consider for now. These are important formula we need to consider for now. Let's solve an example so that we understand what we are saying. Let's solve an example. Let's solve an example. Let's solve an example. Now we have, let's start with example 1. Example 1. Show that cot B plus C all over 2 is equal to cot 90 degree minus angle A all over 2. Now, we don't have to, waste your time. We know that in any triangle, whether spherical or planar, in any triangle, A plus B plus C is equal to 180 degrees. Okay? That the sum of angles in the triangle is 180. So if you divide through, A plus B plus C all over 2 will be equal to 90 degrees. By the time you divide through by 2. Okay? Don't forget, this is like saying A all over 2 plus B all over 2 plus C all over 2 is equal to 90 degrees. That's the meaning of this. If you split it, okay, it's the same thing as saying A all over 2. This implies plus B plus C all over 2 is 90 degrees. I hope you understand. It's the same thing. If you divide through by, okay. Now, looking at what we have here, because our main target is to show that cot B plus C all over 2 is equal to cot 90 degree minus A over 2. So we can split from here now to get B plus C all over 2. We can make B plus C all over 2 the subject of the formula here. So we take A all over 2 to this side. Okay? Yeah. So we take A all over 2 to that side. So that is saying that is A all over 2 plus B plus C all over 2 is 90 degrees. Yes. So, B plus C all over 2 will be 90 degrees minus A all over 2. Fine. If you take cot of both sides, taking cot of those sides, it will be what? Cot B plus C all over 2. I hope you understand. If you like, I'll put it in bracket. You might like it. It will be cot 90 degrees minus A all over 2. You can close this one. So this one is direct. You can leave it like that. So you can see that we have shown that. We have shown what we are asked to show. We have shown what we are asked to show. Now, in the second video, we will continue with more example on the application of Napier's rule. Stay blessed.